So I think we are currently recording. Good. Just let me double check. Yes. Okay. So the rapid development for AI has made it increasingly easy for you to get the code. In the old days, you need to consult experts, you need to read technical documents, but nowadays you just need to describe your needs to AI and it will give you something that works in 90% of the case. This means it's become kind of trivial to just remember the correct function or the correct argument to use. But at the same time, we are also facing like an explosion of data collection and analysis technology. Every day, if you go to like those nature methods, nature biotech or science, all those papers, you will see lots of methodology paper for either collecting data or analyzing data are coming out. So it's very critical that you understand how to use them, because like even if they wrong, like seemingly produce no errors, you can still have logical errors, meaning that you are not using them correctly. So this class will emphasize to tell you how to understand the code and write the code and incorporate others' code as your own code without any misunderstanding. We will give less emphasis to like, oh, you must remember this function because it's very important, because we are now in the age of an AI. But oh, don't worry, we will still teach you how to do those very basic stuff, like how to write a function or whatsoever. So in this lecture overview, so we will look at some basic concepts in R, and then how, most importantly, how to solve a problem by using R. What I want to emphasize is something you should not do in my class. So first, you definitely don't need to have any experience in coding, and you don't need to have R and R Studio ready to run in this on your computer. We don't need that much. And these two things I want to emphasize. Please, like when I was talking, please focus on what I'm telling you, not trying to reproduce the code on your R Studio to confirm it indeed works. It will work, and it will not run away after class. It's fixed on the script. And try to memorize the code after class. To be honest, some of the codes, I don't even myself remember it. So there is no need to memorize those stuff. And what you should do is focusing on understanding the general concept and try to make them into your own framework of understanding R. Okay, so for today's goal, we will have 3 goals. First, we will show how to install an R and R Studio. And then we will learn about how to put data into R. And we will have a brief starting of how to analyze data in R. And we will continue this part on our second day. So first, R and R Studio. So many instructors will directly say, oh, please download the R and R Studio from the website, and we will begin assuming you have it. But in practice, I still find there is something we need to emphasize about R and R Studio. So first of all, here is how you can install R. They kind of hide it in multiple steps. But anyway, just follow this direction. Don't be scared away by this, like, please choose the whatever mirror you want. Just choose something somewhere in the USA, it's fine. And you may find some of the link is dead, just click other ones. At least one will work. And then for Mac user, download Mac, and for Windows users, download Mac. And I recommend you to use the newest version for the reason we will tell you soon. And then just keep the default settings. There is nothing for you to customize at this stage when you are just beginning to learn R. Like when you later become an expert, feel free to do whatever you want to do. Okay, so once we have the R installed, we can like just run the R. To save time, I wouldn't quit the screen and then really open the R. But anyway, this is the interface you will see. And then, so we can do some random calculations. We can calculate the mean. So the thing is that every time you hit an enter, like say, for example, you write this one, you write square root 5 times 6 plus 0.5, and then you hit enter, it will immediately give you the answer. So it kind of behaves like a calculator. I mean, calculator is good, but in some, like in most cases, we don't want it to immediately run the code when we are, like, say, for example, designing a very like complex pipeline of analyze the data. We first write all the code, and then when I want you to run, you run it. So all in all, it means we need a way like to help us write codes in a more like user-friendly manner. So then it comes to the what's so-called the R Studio. So R Studio belongs to a more general type of tools called Integrated Development Environment, aka IDE. So IDE just helps you write codes more conveniently and happily. And here is you can download you can download RStudio from RStudio's website. Don't go to R's website. They are separate. And here would be here would be the what you will see after you open RStudio. This is kind of I will still choose to go to RStudio to give you a sense of how it works. Okay. So for those of you who are on Zoom, can you see the RStudio right now? So just if anyone can just unmute and tell me it's working.
No, we can't see it.
Sorry, just see anything on chat. Oh, okay. Yes, I need to share again. So. Yeah, anyway, sorry for those on Zoom. Perhaps because it's anyway a very trivial demonstration, so perhaps I will not insisting on like having it also on Zoom. So but don't worry, you don't lose. So here is the general interface on RStudio. So what we can do is that we can select the code we want to run and then run it. So if you plot something, it will show at the lower right corner. So which is very convenient. So you immediately see the output and everything is organized. Your code is on the top left corner and your text output is in the lower left corner. Images will be output on the lower right corner, and your variables, which we will mean what's the variables, will pop up on the top right corner. Okay, so let's go back to the, yeah, this is just a quick demonstration. So annoying, I think. Why the share just stops? Yeah, it turns out if you are good at R, you are not necessarily good at Zoom. Yeah, yeah, second. So can people on can people on Zoom now see the? Oh, I think I should.
We can see it, but okay, now.
Yeah,
we can see it now.
Can you guys now see the slide again for everyone on Zoom?
Yes.
Okay, yes, thanks God. Yeah, so here is just a summary for you to see how the RStudio's interface look like. So for anyone who missed it on Zoom, for my demonstration, it essentially says the same thing. for these slides. So overall speaking, you can see now it's a much user-friendly interface. So that's why we will use RStudios. Okay, so here is a summary. So through most of the time, unless you are super hardcore, you will interact with RStudio to write your codes because it offers lots of easy to use function, as you will soon figure out. So whenever you like write the codes wrong, like having some bugs, it will highlight that line telling you perhaps there is a bug there. It like nowadays, it can even guess which function you are trying to type. So you just need to have a blur memory about the function name, and it will try to suggest which one is the one you want. And when you finish all the codes, what you can then RStudio will just pass your codes to R to do the final interpretation and run your codes run your codes to produce the results. So it's still R running the codes and produce the results. RStudio is just there to help you write those codes. Okay, so we will have our first exercise. It of course wouldn't be graded anyway. So just for you to check your understanding. So let's think about scenario like for those undergrad, if you go to graduate school, like your boss introduced you to a colleague who is very good at R and bioinformatics. So, and during you guys' first meeting, so you find that he was using something called VS Code to write R code. And now, which is quite different from the one I teach you, which is RStudio. Like to make things even more complicated, he show off to you that, oh, this VS Code, I have installed lots of plugins and to make it even more powerful. And he wrote you a script for R and throw it to you. So here is the question. So if you want to reproduce the results from that script, should you just open RStudio and run it? Or should you just install VS Code and try to install all the plugins to reproduce the same developing environment so as to reproduce the work from the script? Yeah, I wouldn't ask how many of you guys choose A or B, but just have an answer in your mind. Yeah, so A is correct. So VS Code and RStudio are just different ways of helping you writing a code. It's just writing your like paper or article in Word versus Google Doc. No matter how you write it, the content will be the same. And it's R interpreting it. So it doesn't matter whether you or your colleagues writing it in RStudio or VS Code. Then exercise 2. So after some further talk, so you notice that Tom is using something like R 3.7.1, but yours is R 4.5.1, as I recommend to you. So what should you do if you want to fully ensure you can reproduce the code? A, you just ignore the weird number, like R is R, there is only one R in the word. Or second, you install R 4.3.2 as an additional R in your computer. Or C, like you first uninstall R 4.55.1 and then install R 4.3.2, because if your computer sees 2R, perhaps it will be confused. Yeah, I will just give you 10 seconds to have your own answer in your mind. Then I will explain to you why it's what's the correct answer and why is it. So first, let's understand what's that weird number after R. So it's just a version number. And if you go to R's website, you will see perhaps every month or every month or several months, they will release a new version of R, and they will tell you what's new in this R if you click on the what's new link. And typically, what do they update? So first, they fix known bugs reported by users. There are always endless bugs to fix. They may add some new features based on the feedback from previous users. Say, for example, some people say, oh, this function is too difficult to use. Maybe can we rewrite it in a more user-friendly manner? And finally, a very important thing is that things will also be deprecated, which means they are also trying to simplify the whole framework for the purpose of easy to maintain code, which means if they find something is too outdated, like no longer in use, they will typically deprecate it to avoid the whole source code become too large to maintain. So indeed, developers work very hard to ensure the newer version is backward compatible with old version, but practically it cannot be guaranteed, especially if you have a too large gap in version. So first, you may think the first question is that, is it always the better to use the newer version? In most cases, yes, because it contains fewer bugs and more features. However, be aware that if you go to the lab, you will know that there will always be an old computer running on Windows 7 or Windows XP or Windows 95 to support that old but super important microscope or whatever. And if you upgrade, then everything shuts down. Similarly, like perhaps every lab more or less have some like 10 or 20 years old codes from an old postdoc or from your own PI when he was a graduate student. And likely those codes are run on are written based on an older version of R. And in this case, if some function or feature used in that R was deprecated due to the large version gap, then you can no longer use that code. So for that reason, if you want to reproduce results from a very old code, it's a good practice to ensure you are using the same version of R as it was written in. So luckily, in addition to just publishing the newest version, R also collect most of the old versions as an archive. So it's a little bit difficult to find, but you can still find it on R's website. So I have already found it for you. So it's just click the link of previous release, and then you will see like tons of different R's versions pop out. And to make things even better, so you can actually choose like different versions of R. You can install different versions of R at the same time on your computer. And RStudio just give you an interface. You go to Tools and then Global Options and then General. So you can choose which version of R will interpret the code you write. So if you want it to interpret old code, you just switch it to an older version of R and then restart RStudio. Everything will now be on the older version of R. Say, for example, this is the screenshot from my own PC. Like 4.3.2 is what I used during when I was a graduate student. When I become postdoc, I decided to use something new, 4.5.1, because all the old project kinds of end and I have a clean start. And 4.4.0 is the one I use to teach this class because I want to separate it from all my data pipeline to avoid accidentally messing up something. Yeah, all in all, you can have whatever number of versions of R you want and switch freely between them with RStudio. So going back to this exercise, I think you guys more or less have the answer in your mind. So the correct answer is B. So there is no need for you to uninstall your newest R. Just install the older R and then reproduce the code with 100% face. And one thing is that still it's some work to install a new R and switch between. So here is my personal advice on the version difference. So you can see there are 3 digits, X point, Y point, Z. So if X is different, you'd better upgrade or downgrade it because the first number is the biggest one, which means a huge difference. Sometimes even the whole designing principle changes, like Python 2 versus Python 3, R3 point whatever versus R4 point whatever. And if Y is different, so if you just want to have a test of the codes, perhaps you don't need to switch the version. But if you guys decide to collaborate for long term of a big project, I will still recommend you to align the version you have. And if Z is different, really it's fine, but just keep in mind that you have a gap in versions. So here is a homework questions. So for those who are taking this for credit, please hand me the answer of it 2 weeks after the end of this course. I will send you a separate email summarizing all the homework answer you need to get, and then just answer me like 2 weeks later. For those of you who are not taking this, just think this a take-home questions. I wouldn't immediately explain it in the class, but after 2 weeks, I will get the answer to you. So here is, okay. So RStudio is also constantly updating. Like, do you need also to match the version of RStudio or not? Okay.
Is your homework open book, open notes, open internet, or no?
Yeah. Just open whatever. Just don't copy from your friends. That's my bottom line. Yeah. You can even ask AI. I don't mind. Yeah. So here is the conclusion for section 1. So we see how to install R and RStudio, and we know the general concept behind them is RStudio is an integrated developing environment, while R is the true programming language doing the code interpretation behind it. So we learn how to handle the gap in versions. That's perhaps something you guys will more or less encounter in the future. So I hope you can remember this. So the take-home message is that, as you have already seen, is that learning R isn't about just open it and then begin to write codes. You have lots of concern other than having a code typed in front of you. And we will see more and more of them when we go through the class. Okay.
If I work in a field that primarily doesn't use R, how do I start using it, and how do I convince other people to use it?
So first, respect your fields. If your fields doesn't use R, there is a good reason why they don't use R. Say, for example, I also use MATLAB. So if I'm doing image analysis from microscopes, I wouldn't use R. Even if you point a gun at me, I wouldn't use R. Yeah. So it's in lots of cases about where the gold standard package is. So MATLAB has very powerful support of say, for example, image analysis. It is a very powerful image analysis toolbox. So that's why whenever I have image to analyze, I go to MATLAB. And vice versa. Even if you point a gun at my head, asking me to analyze sequencing data in MATLAB, I will still do it in R. So yeah, don't convince other people to use R. Just try to align them. That's also one reason why I say that even if you already know a programming language, you should still add R to your toolbox, but because maybe one day you just begin to collaborate with some people who are diehard fans of R. Yeah. So now let's move on to section 2. So put data into R, or if you feel this name is not like fancy enough, so you can show off to your friends, you can also say it's data type and data structure in R. So to begin with, we all know the joke of how to put an elephant into a fridge. We have a similar version for analyzing data in R. So you open R or RStudio and put data into R, and then you analyze it. So this section will focus on the second step, which is put data into R. So then how do we put data into R? So we use one line of magic code. You see my first variable and then an arrow sign and then something like a number. So it can be broken down into 3 parts. So first, that's the green part, my first variable. So this is like the container holding your data. And you can name the container like based on your own flavor. You can name it whatever you want by sticking to some rules we will cover later. And then the assigning symbol, which means the arrow, which means it's like pointing towards from your data towards your container, saying that, oh, I want to assign this data to this container named by me. So you can also use the equal sign if you want. They two are equivalent. And finally, the red part, which is the data you want to put. So once you have a variable holding the data by defining it, so first you can check it by using something called function we will cover later. So you can check it like, oh, what's in my container? Just like you open the container like in your freezer, like, oh, what's inside it? And we can also modify it. Say, for example, you can take the frozen chicken out, bake it, and then put it back. So we can also do something to whatever is stored inside the variable, some numerical manipulation, say, for example, as shown here. And finally, most importantly, we can also create new variables from old variables. So you say, for example, here we do some operation on the old variable and then store the results into a new variable. Then it comes to the first very important concept in R. This is very important. So what's the so-called 6 basic data type in R? So we have just like how we like categorize different data when you take the course data analysis. In R, the programming language itself also has a rule of defining different data types. So first we have numeric, which is just numbers. You can have whole number, which is 1, 5, 6, something like that. You can also have fractional number like 1.3, 6.5. And the way you define a numeric is just as the simplest one, just as we showed before. You just have the number and then assign it to your variable. And then we have something called integer. So as its name indicates, it's integer. But to let R be aware that you are giving it an integer, you add a keyword letter L after the integer you want. So it's 1L, 2L, 10L. So R will ignore, R see the L and take it off, saying, oh, this means it's an integer, and then keep it. And the complex number, so if in the future you work in the field of physics, perhaps you will deal with it a lot. You guys all know what complex number is, right? But don't worry, biologists are stupid, so we won't use complex numbers that much. And another thing is character. You may also hear someone refer to it as string. So string and character are just equivalent in R. And throughout this course, I will just call it a character. So a character is something different from numbers. It's like text. And to make R aware that you are parsing a text to it as a data, you need to surround your text with either a double quote, or if you are lazy saying that I'm too lazy to push that shift sign, you can also use single quote. They two are equivalent in R. So either double quote or single quote surround the text you want to pass. So anyone want to guess like why you won't need a double quote? Why you cannot just like using a number, just like use the number you directly type it? Why we need a double quote or single quote? Okay, so it's just if you just pass, say for example, hello to R, R doesn't know whether it is a variable's name, which means the container for holding the data, or do you want to mean a text? So that's why we use the double quote or single quote to specify it's a text. And finally, there is a very important one, but very simple one called logical or Boolean in some contexts. It's either true or false. And the true must be all capitalized, spelled in TRUE. So it's something called keyword, as we will see later. And finally, another data type called raw. Don't worry, you will never encounter it, I guarantee. Yeah. To be honest, when I only know raw is one of the basic data type when I was preparing the teaching material of this class. So yeah, you wouldn't like encounter it. So finally, so then comes to a very important thing is how can you name your variable based on certain, like you need to stick to certain rules. It's not 100% your own freedom. So first of all, it can only contain letters, digits, underscore, and a period. So no @ sign, no $sign, or whatever other signs. And white space, sorry.
A variable can be any of the first 4 data types other than logic, right?
A variable can also be a logic.
Oh,
Yeah. I mean, you can put any data type you want into a variable.
got it.
Yeah. So you cannot have white space. This is very important because white space means breaking things into 2 parts. It's quite complex for R to know whether you mean 2 variable or 1 variable. So you cannot have white space in your variable name. But what if you really want, like it's actually quite handy to use underscore. So people typically use underscore to replace white space because it looks similar to a white space. And it can only begin with a letter or a period. So you cannot have it begin with something like a number. And I also do not recommend you to begin with a period because it's not very commonly used practice. Really just begin with a letter or a word. And variable names are case sensitive. So unlike your email box, it's case sensitive, which means capitalized letter versus uncapitalized one, they are treated different. It's, yeah, you must, sorry.
Can I end with a period though?
End with what?
Can I end a variable with a period though?
Yeah, you should be able to.
Okay.
Yeah. And finally, a very important thing is that variable names cannot be keywords. So R reserve some keywords to be used by you. Say, for example, true, which means the logical type, rather than a variable. You cannot assign, like have a variable's name that's true. And other reserved keywords, as we will soon see, are like now, if, and for. So then you must be like wondering like, oh, why can't I just ignore data type? Why do I need to learn about data type? So here is an exercise. So try to guess what will happen. So for the first 3-line code and the bottom 3-line code. Due to the complexity of switching between R and the presentation mode, I will just not switch to that. But don't worry, I will describe to you what will happen. So the first code will work perfectly fine. So you have A as 10, B as 3, and you print A plus B, it will give you 30 as expected. However, if you do it like the second case, R will just throw an error at you. And the reason is because you surround the 10 with double quote. So you are telling R, oh, I'm giving you a text. Even if the text looks literally like 10 to you, R will treat as a pure text rather than number. So for R, asking it like what is 10 double quote plus 1 is equivalent to asking what is I love biology plus 1. So it's fairly defined. Like you never know like what's a text plus another text, and like your math teacher never teach you how to do that, and R also doesn't know how to do that. So that's why we need to care about data type. And if you ignore it, you will have lots of errors thrown to you by R. One final words for those who want to be more advanced in R, for those who want to have a very rigorous definition like across all data types. One thing you may notice is that we can pass like whole number like 1, 2, 3 to numerical type. But at the same time, we also have 1L, 2L, 3L to define an integer type. But integer itself, mathematically speaking, is a subset of numbers. So why we still want to have an integer type in R rather than just numeric? So the reason is because when you pass integer number to R as numeric data type, deeply inside R, it stores it as a number with a very, very, very tiny error, tiny to the extent you don't need to care about in most cases, but it's there. So for those who want to do super accurate calculation, there is a field on that where that tiny error can accumulate into a big error. Then you need to define it as an integer. By defining it as an integer, there is no error. It's absolutely the number you pass to it. But the downside is that you cannot store a very large integer. So this number, this 2 whatever one, is the largest you can have for integer data type in R. Or if you have some fancy machine, you believe it can be bigger, you can use this code to check it. I guess it's somewhere, but it's something like this. For numeric, so do you?
Yeah, can you convert between numeric and integer?
Sorry?
Can you convert between numeric and integer?
Yes. So he is asking, can we convert between numeric and integer? So this is something we call as coercion. So we will touch about this later. So yes. So variables are not separated by hard walls. Like sometimes R will convert, you and R can convert them in between, as we will soon see. So of course, for numeric, there is also an upper limit of how big you can have, but the upper limit is much larger. So the exact reason for this behavior is beyond the scope of this lecture. In practice, you can treat for integers you want to use, just use numeric. Perfectly fine, 99.99% of case. Yeah. So then now we have learned about the data types. So let's move on to something more advanced. So many of the data we are collecting nowadays will make more sense if we can organize them in a specific way. Let's say experimental science is all about replicates. There is a very famous sentence saying that n equals to 1 equals to nothing, which means you cannot conclude anything from just one replicate. So let's say we collect like replicates for an enzyme's activity before drug treatment. Currently our way of storing it is that, we need 4 different variables to store it, like replicate 1, 2, 3, 4. Like imagine you have lots of experiments and then you soon end up with hundreds of variables. But it actually makes more sense if we can group them together. Like for one condition, we group all the replicates together. That's how we human beings tend to think. And you can do this by using something called a data structure with the name vector. So if you want to store 4 replicates, you just surround them with a round bracket and put the number C before it to create a vector and put it into the variable. So we can see, I will show some immediate advantage of doing this. First, if you say, okay, if I do this, where is my each replicate? You can simply access them by using the square bracket and the index correspond to each replicate. Say, for example, if you want to have the third elements in the in this vector, you just put 3 there, and it will give you 5.
So for all computations here, R enumerates everything from 0. Sorry, from 1.
Oh, good questions. Yeah, that's a very good question. So he is asking that for the first element in the vector, is it 1 or is it 0? So because many programming language count from 0. So here R counts from 1. So which means to get the first element in the vector, you use square bracket 1 rather than 0. Yeah. For those of you who are confused about what's 0 and 1, just the first element is 1. Yeah. R is more humanity than other coding language. Like Python starts from 0. Yeah. So one immediate advantage is that it makes it easier for you to analyze the data by grouping them into the vector. Say, for example, after you do some measurements, frequently there will be some background noise you want to subtract from your measurement to reflect the true activity. In the previous case, if you store it as 4 separate variables, then you need to modify them one by one. But in this case, if we group them as a vector, then we just subtract this, like say for any value correspond to that background from the vector. Then all the elements in that vector get subtracted all at once. So you don't need to do it one by one. So this is one immediate advantage. And in the future, you will see more and more. I just want to give you an example here. So just like there are basic data types in R, we also have basic data structures in R. So to put it simple, like what is a data structure? It is a way to organize your data. And different data structures is just different way to organize your data. So in R, we have 6 different data structures, basic data structures. So vector, factor, list, matrix, array, data frame. And we will go through them one by one. So first, vector, we have already seen. So whenever you see a data structures, just ask yourself 3 questions. How to create it, how to access individual elements in it, and what rules do I need to keep in mind about those data structure. First, how to create a vector. You use the magical word C, followed by round brackets, and then put all you want to put in the into the vector and separate each element by comma. Yeah, so that's the grammar for defining a vector. And a vector can hold numeric data. As you see here, I just use numeric rather than L, 3L, 10L. And it can also hold characters. Like you can break up I love biology and then put them into vectors. The second question we have already seen. How do we access individual element in a vector? Square bracket followed by following the variable name, and then put the index of the element you want to refer to, 3 or 4 or 1. And what rules to keep in mind about vector is that all the elements in one vector must be of the same data type. So I put 1, 3, 8, 10 to this example vector. All of them are numeric. If I want to store like text or characters, then all of them in that specific vector must be character. So different vectors, it's fine. Their data type can be different. But within one vector, the data type must be the same. But the human nature is just kind of rebellious. So if I told you not to do something, I guess at least some of you will try to do it. Like, oh, what if I just try to fool the R by putting in like different data types in the same vector? So what will happen? So let's see. So I'm also rebellious by nature. So I have already done it for you. So let's say we create a vector by putting 1, 2 up to this step. It's fine. Then we put hello in it, which is a character. So what will R respond? So first, it doesn't give you any error. But then, as you notice, it silently convert 1 and 2 to character for you, as indicated by the double quote. Let's see another example. So this example, we first have true, false, which is logical. And then we have hello again. Hello is just my way of messing up stuff. So then, as you notice, it's again true become like text true, false become a character like false. And finally, what if we mix numeric and logical? So it's, you see 1, 2, true, false, and then true is converted to 1, false is converted to 0. So this means R stick really hard to its rule that you must have the same data type in a same vector, but it also wants to do you some convenience by silently converting some data type to you whenever possible. So the reason here, 1 and 2, true and false are all converted to characters is because it is always guaranteed to be able to convert from numeric or logical to a text because you just add double quotes. But if you want to go from double quotes, a character to a number or to a logical, it's not always guaranteed. Say, for example, what's hello if you want to convert it to true or false, or 1 or 2. It's a clearly defined mapping. So that's why R always convert it from number or logical to character. So what is happening is something called data coercion. Or you can think it's just conversion. So this behavior is not limited to putting different data types into a vector. It's a more general behavior. Whenever R finds that you are asking it to do something that violates the data type's rule, it will try to coerce the data to the correct data type to see whether it makes sense or not. And if it makes sense, it will just do it for you. So as you can currently, if I guess in your mind, you think, well, this is such a like evil function, like R silently do stuff for me, mess up my data. So if you are unaware of it, and if you are poor at managing data types, this can indeed be a nightmare. But as we will soon see on day 2, an example will show you, if you have a very clear mind about data type, you can take advantage of this behavior to make your life much easier. Like what takes 10 lines of code to achieve can be achieved with just 1 line of code if you can use data coercion smartly. So don't skip tomorrow's class. Like otherwise you will never know like how to take advantage of data coercion. Then let's move on to the second data structure, which is factor. How do we create a factor? That's easy. You just put factor followed by round bracket around a vector, and then it's a factor. So, and how do you access individual elements in a factor? It's also easy. It's the same as the vector. Then what's the difference between factor and vector? So factor is designed to make it easy for you to handle categorical data. So each category is treated as something called a level in a factor. Say, for example, we have A, B, A, C. There's something like the grade, like teachers assign to students. So clearly there are 3 categories in it, which is A, B, and C. So each category, please note category, not the data itself, is stored as level in the factor. So when we using the factor command to convert a vector into a factor, R will automatically identify all the existing category in it and then store it as level and link all the data, all of your data, or assign all of your each of your data to a specific level, or you can call it category. So let's have a quick test about like which of the following data set or data is suitable for being stored as a factor. First, student's grade, ABCDF. The activity of an enzyme you measured in your lab. So to make things easier, let's assume it's any value from 0 to 100. And the nationality of UCLA student, US, Chinese, British, Korean. And the faculties in QC bio program, who is generously sending their postdoc to teach this class, so for free. Yeah, yeah, like Alexander Hoffman, Roy Warman, who is my boss, so etc. Yeah, it's multiple. You can have multiple answers. This is not like it's not limited to just one correct answer. Okay, let's analyze them one by one. So first, if you want, I will take all these data as vectors. It wouldn't give you any error. So our main discussion here is it worth it or not? So for example, for the B, the enzyme activity, so it can take any number like 1, 1.5, 2.3. So it's highly likely that your data, like each of your measurement, is something unique. Even if 2 of them happen to be the same, it doesn't make lots of sense to put them into the same category. And think about this, 1.3 and 1.31 are 2 different categories. So all in all, you can expect infinite amount of categories. And to make things even worse, so R treat each level as a character. So which means now you cannot even do numerical operation on your numerical enzyme activity data, which means you can no longer subtract a background value from these if you store them as a factor. So it doesn't worth it because first, it doesn't make any sense. Second, it limits what you can do to your data. A and C are clearly categorical. And we can expect multiple students will have the same type of grade, like B or C, and multiple students will have same nationality. So it makes lots of sense for us to store them as, sorry.
So what you have for when you have multiple grades, are you saying that every student will store so if you'll have all the students who scored an A in one category and then all the students who scored a B in another category and so on?
To put it more correctly, it's like they are linked to that category. So let's go back. Say, for example, in this case, A, B, A, C. When you put it as a factor, R does not mess up the order to group A together and then B, then C. R still preserve this order, but for each of the A, it's connected to the category to the level of that factor. Means R knows that it belongs to the A category. So R does not mess up the order trying to group them. R just link them to the category.
So this means that 1, 3, and so what R thinks in its mind is that 1, 3, and 4 are in the A category.
Yes, 1, 3, and 4 are in the A category. So and if you print 3 here, it's A. Yeah. Thanks for bringing this up. Okay, so A and C are clear categorical, and we expect there to be multiple entity for at least some of the categories. So it makes lots of sense for you to group them as a factor. D is a little bit subtle because to the best of my knowledge, we don't have twin brothers in our QC bio program. No faculty have the same name. If you want, you can, but again, it's a case where it doesn't do harm, it doesn't do good, it all depends on you. Okay, so then you must be thinking you have been talking about factor is good for so long, on Earth, what is good about it? So let's do an experiment. First, you use the function summary. Clearly, you just ask R to summarize a variable for you. We first pass a vector of students' grade to it. Here is what R gives you. Okay, it says length is 5. Okay, kind of useful. Class character, I already know it when I define it. Mode character, just same information again. I mean, it's useful to a certain extent, but let's see what if we pass it as a factor. Once we pass it as a factor and then ask R to summarize it, it immediately tells you, oh, there are 3 A in your data, 1 B in your data, 1 C in your data. So whenever I have a data that has category inside, and I want to immediately know within 1 second how many, what's the counts for each category, I always put factor my data summary then. Yeah, and immediately I will know it. So that's one advantage of factor. As we will see on day 3, factor will also have other very useful function in data visualization. So you should also not skip day 3's class. Yeah, which means full attendance. Now let's move on to list. So first, how do I define a list? Oh, as you see here, you have huge freedom. You can put a numeric, you can put a character, or you can even put a vector into a list. So yes, list is kind of a super freestyle vector. So it can hold anything. You get virtually anything you give to it. And each element in the same list doesn't need to have the same data type. And but then you immediately see some price you need to pay. So when you ask how to access each element in a list, you get 2 answers, and they are not equivalent. The first is perhaps something you are more familiar, like the square bracket one. It will give you the ith element, like the first, second, as a list. So which means even if you put 1, which is a numeric data as the first element, if you use example list 1 for with 1 square bracket around it, you find what you get is a list rather than a numerical data type. But then you ask, where is my 1? I want to get it. You need to use 2 square brackets and to refer if you want to give the exact content of the element you want. So yeah,
Does this mean that you can do so lists can take in like lists inside of lists,
Yeah, you can list can take lists
but
inside list.
vectors and factor cannot?
Yeah, vector and factor shouldn't be able to take list. I will double check, but they shouldn't be able to take list. Yeah. Then what rules to keep in mind for a list? So first, unlike vector, elements in a list can have different data types, and they can even be different data structures. So it doesn't need to be a basic data type. As you can see, you can put vector or even another list as an element inside the list. So it becomes a nested list. But the price you need to pay is regarding how, and actually it goes hand in hand with the flexibility of the list. So why list is able to do this is because, like, for whatever data you give it, it put it into a container, just like the glass box you use for storing your food. It doesn't like you put in vegetables, meats, snacks, whatever in it, and then put them into fridge so they won't touch or squeeze with each other. List is also doing the same thing to avoid the different data types explode R's mind. It put each of them as into a container and pass all the containers to R, saying that see, everything is a list. So you don't need to worry about different data types. But the problem is that you need one more step. When you take out the container from the fridge, you should not start eating it because you need to open the container to take what's exactly inside out. Then that's safe for you to eat. So that's why you have a little bit counterintuitive extra step of the single square bracket and double square bracket. When you use a single square bracket, you only take out the container. You haven't opened it yet. If you really want to eat it, keep in mind, like you need to use the square bracket, double square bracket to open it, and then you are safe to eat. Otherwise, your teeth broken. Yeah. And I'll throw an error to you saying that I don't know how to do like plus operation to a list. So, but at this point, perhaps you will have some smart idea in your mind saying that, oh, because I'm not good at data type at this moment, why not I just use list instead of vector completely because it's so nice. It's like so flexible. And I already know that the square bracket and double square bracket. So let's do a quick experiment to see how it works. So first we store the vector, we store the replicates as a list. And then we want to do the background subtraction again from this list instead of a vector. So, yeah, I should run this in R, but I will tell you, I will throw an error to you saying that it doesn't know how to do numerical operation to a list. So the thing is that although lists give you huge flexibility in different data types together, you lose something. Say, for example, even if all of them are numerical data type, you still wouldn't be able to do numerical calculation with it. Because from R's point of view, it's all containers. And containers plus one is something not defined to R. And you have this extra trouble. And finally, as we were talking day 3, your code will look quite confusing to the readers. Say, for example, if someone see like, oh, you store all the replicates, like which are numerical data type in a list, they will begin to think, does this mean I'm also supposed to put some characters or other variables into it? Because this guy is using a list rather than a vector. So there must be some reason behind other than this guy is lazy and bad at data types. So it can be very confusing when you see like someone trying to use list to hold like numerical or character data simply for the purpose of being lazy. Okay, so let's move on to matrix. Matrix, all of you guys have learned it in high school, I guess. Yeah. it doesn't mean the few matrix. So it's data organized in a two-dimensional manner. So for all the ones we have introduced so far, it's one-dimensional. It's list, vector, factor. It's all organized along one dimension. Now we upgrade, we go to two-dimension. And here is how you define it. Again, you separate, you surround a vector by something called a matrix, followed by a round bracket. But this time it's a little bit more complicated. It's like you also have something like unrow equal to 3, uncol equal to 3, and byrow equal to 2. So we will explain in section 3 what on earth these are doing. But currently, I guess more or less you can guess. So it's like you pass R, a 1D vector, and then ask it to form it into a matrix. But R will ask, a matrix can have different numbers of rows and columns. How do you want me to shape it? And you tell R that, oh, I want a matrix of 3 rows and 3 columns. And then R asks you, okay, do you want to put each number, like, do you want to put 1, 2, 3 like this? Or do you want to first put it along the column, like 1 and 2, like 1 below 1 is 2 and below 2 is 3, or 1 to the left of, to the right of 1 is 2 or 3. It's either by field by row or by column. So then similarly, how do you access an element in the matrix? Because now you are 2D, so each element in the matrix is defined by a coordinates rather than a single element, just like how you define everything in spatial coordinates. So to get the elements in the first row and the second column, you do something like 1.2. Yeah. So what's the rules to keep in mind about matrix? So first, you have a 2D rectangular organization of numeric data. And rows is count from top, which means the top row is regarded as the first row. Columns is counted from the left, which means the left column is the first column. And when you refer to the coordinate, it's row by column, which means the first one here, the first element in the square bracket is the row number, and the second one is the column number, like row by column, row by column. Yeah. Okay. So you will be wondering, like, I'm not a mathematician. Why do I need a matrix? I mean, if you take course linear algebra, you will be tortured by like matrix for 1 semester. Yeah. But you will be wondering, like, as a biologist, why do I need to like learn about matrix? Okay. So your supervisor decided to run, it's the age of omics. Like everyone is talking about proteomic, transcriptomic, epigenomic. Everything becomes, big data. So your supervisor also wants to join this wave. So he wants to run something called RNA-seq. So it's a technology capable of measuring virtually all the RNAs, different types of RNAs in your sample. To give you a rough idea, it's around human being have around Homo sapien have around 20,000 protein coding genes. And actually this technology can measure more than that because there are other non-protein coding genes. So then you run 3 replicates for before drug treatment and after drug treatment. So you have in total 6 RNA-seq data. And now your supervisor now wants your colleague to analyze the data for you to pick up those genes that are significantly up or down after the drug treatment. And Tom said, okay, no problem. Just give me the count matrix of your data. So just have 10 seconds to guess what a count matrix will look like. I mean, it's a matrix. So first, it's not something make up like by me randomly to show you the importance of matrix. Count matrix is a frequently used concept in omic level data sets in biology. So in a count matrix, each column belongs to one sample, and each row belongs to one feature measured by the experiment. In our case, it's RNA level. But if you want to become a proteomist, then each row is a protein. So you have 3 replicates for 2 conditions, and for each condition you measure around 20,000 different RNA for within that condition. Therefore, your count matrix is a 20,000 by 6 matrix. Okay.
I'm guessing your data type is whether the gene is on or off.
Oh, no. It's a number, like how many. So it's a number like 500, 600. That means the sequencer counts how many sequence belonging to that gene is in your sample. So it's a numeric data rather than just on and off. Yeah. And by the way, even if you have simple on and off, matrix can hold it because you can have a logical matrix, which is on or off. But in our case, this is a continuous numeric data type. So if you take a counts matrix and then print 2, 3, the second row and the third column, then you will get the RNA level of the second gene, whatever is there, in the third replicate, which is likely the first, in the third replicate of the first condition. I assume you order it like before drug treatment, replicate 1, 2, 3, and then after treatment, replicate 1, 2, 3. Then you will get the third replicate of the first condition. Okay, now a quick visit to array. So array is just matrix of any dimension. So if you want in the future to become AI engineer or whatsoever they call it, you will learn something called tensor. Like in Google's famous Python library for deep learning, the TensorFlow. So it's similar to tensor. It's a generalization of the concept of matrix, saying that you don't need to bind yourself to 2D. You can have any dimension, like 3D, 4D, 5D, 1000D. So an array allows you to generalize matrix to any dimension. A 3D matrix is something perhaps like if you go to the hospital and then the doctor run a CT scan on your brain. So because your brain is 3D, the final image is also 3D. So you can store the image as a 3D matrix where each element corresponds to the value of 1 pixel. And if you run something like supersonic, like colorful supersonic or something like that, you get a colorful image, which is RGB based. Then you have 3 3D matrix. One is for R, one is for green, the other is for blue. So 3D matrix is frequently used to store 3D images. Some even higher dimension ones, mathematicians have really loved it. So, and finally, a very important one, data frame. So data frame is another way of generalized matrix, but slightly different. You don't go towards like very high dimensions. Instead, you make it more human readable. So data frames allows you to define like column names, and at the same time, for matrix, it's similar to vector. All the data type must be same. Vector, the data frame reduce this constraint a little bit. It says you can have different data types as long as they are in different columns. Say, for example, here for column 1, I can have numeric. For column 2, I can have characters like A, B, C. And how to access each element in the data frame, I show you 3 different ways. So first, you can use the similar way just like a matrix. Use the row by column. Then you can also use the column name if you give it one. And finally, you can use the $sign after the data frame, and then followed by the name of the column, and then a square bracket to refer which row you want. I really love this one, the one followed by $sign, because I mean, when the data frame is complex, when it have many rows, how the goddamn can I memorize all the column numbers? But once you in RStudio, you click dollars, you put $sign after a data frame variable, RStudio will automatically pop up all the column name, and you can choose one from it. So you don't never need to memorize all those column names.
So it'll pop up all the column names and tell you like what is in each column, or
yeah. So perhaps during the break, during our first break, which is coming soon, I will switch out and then maybe let you guys see how it works. Yeah. So again, what rules to keep in mind for data frame? So it is a generalization of the matrix. You can hold different data types in each column, but within one column, keep in mind the data type need to be the same. Each column must have the same length, which makes sense. You can use the $sign followed by the column name to access a specific column. So exercise 2.5, maybe after finishing this one, we will have a rest. So you show the counts matrix to Tom, and then you are about to leave. Tom stops you and say, it's not enough. I also need something called metadata in addition to the count matrix. Okay, he then explains to you that because you just give me the count matrix, how can I know like the exact experimental information related to each column or each sample? Like, is it treated or not treated? Like, does anything happen during the data collection process? So I need a metadata. So try to guess like, what is a metadata and how is it stored, like usually in R? By the way, this is also not something made up by me. Metadata is frequently used concept. Okay, so for an RNA-seq experiment, metadata typically looks like this. First, you will have sample ID, just an ID for you to identify what sample you are using, what sample you are looking at. Then, because you are using a drug, then we can say we can have a column dedicated to drug. Vehicle just means anything used to dissolve that drug, water or DMSO. And then you have some weird name for a drug. I think that's a drug used during my PhD to inhibit whatever enzyme. I already forgot. And then, of course, you can, whatever you want to put related to the experiment. Say, for example, all the treatment is run on the HeLa cell line. And then you can also have comment, which is quite important, to record anything that happened during the experiment that you want the analyzer of the data to know. Say, for example, like after you collect all the RNAs, you do a quality control on that RNA and then find, say, for example, the replicated 2 from the treated group has relatively low RNA quality, but your supervisor asks you to send it anyway. So here, so this is all in all how the metadata will look like. Feel free to add more column if you feel necessary to add in extra information. And you can create this data frame as what we have just shown before by here is the each column name and what's to put them as a vector. I just use ... to avoid it becomes too long. So as you have already noticed, data frame can be regarded as R's equivalency of Excel spreadsheet or Google Sheet. So that's the reason why it's perhaps one of the most popular used how to say data structure in R. And on day 3, and day 2, we will introduce to you how you can manipulate a data frame, just like how you will manually do it in Excel and Google Sheet, but in a more smarter, cleaner, better way. Yeah. Okay, so I guess 1 hour passed. For humanity reasons, everyone is allowed to take a rest. Yeah, and yeah, I think we will let's gather back after 10 minutes. Yeah. Oh, so yeah, for whoever wants to see like whatever will happen, like why like the dollar sign, I just define a data frame and then dollar sign. It automatically pops up the column and what's inside it. So you don't need to memorize the name of the columns. That's it.
Kimbo, can that data type you talked about be used for non-biological data as well?
Oh, sure. Just for this class, I guess everyone is biologist here, so I try to make context for everyone. But I mean, it generalized to any tabular data or any type of data. Yeah. Oh, so if anyone is on Zoom, can you tell me whether now you can see the RStudio
Yes, we can.
interface? Okay, perfect. Okay, so just for everyone on the so for everyone on Zoom, I will just show you what I mean by the $sign just automatically brings up everything, so you don't need to memorize the column name. So it's like I define an example data frame and I type the variable name. And now if I click $sign, then it automatically pops up the column inside it.
I'm sorry, but I
further
can't
the
see
right
it
of
anymore.
that column name, I can see what's inside it. And if I scroll down, then it will tell me the other one. And if I'm satisfied, say for example, I want to select column 2, I just click tab and it will
You
automatically
pause the
fill.
screen share. I
So
think it's
even
not
if you have a
moving
very
anymore.
long column name, you can just, it automatically pop up for you. Yeah. And also you guys perhaps miss the demonstration at the beginning. So yeah, let's also do this to catch up. So what you can do is
Hello,
you
can you
select
hear
the
us?
line you want to
Hello?
run, and then click this run, and you can keep running. Every time it finishes one line, the cursor immediately move to the next line. So if you
Hello, your
keep
screen
click,
is
it
not
will go
moving.
through all the lines you have. Or if you want to run multiple lines, you can just choose all of them and then click run. Yeah. So that's how you run codes in RStudio. Oh, I have. Oh, still come? Oh. Next. So I will do this again. So yeah, I guess so the screen is now scrolling, right? Okay, so now the screen is moving, right? Okay, so let me do the demonstration again. Oh, good, because now everyone is here. So first the $sign one. So yeah, it's good. So for R, it also, even if you just type part of the variable name, the RStudio will try to come up. So here I already see the data frame popping up, so I can use tab to automatically complete it. Then I click the $sign, and then the column name, all of them will pop up, and I can scroll up and down. I can scroll up and down to see what's in each column. And whenever I see the one I want, I can use tab to automatically complete it. So then this finished the selection of a column without the need to memorize the column name. And for the demonstration at the beginning of the class, so you can run line one by one, by move the cursor to the line you want to read, you want to run, and click run, run, run. Or you can select all the codes you want to run and then run them all at once. Yeah. So everyone on Zoom see it, right? Okay, perfect. So I do not owe you guys anything, so good. That's a good start. So let's go back to the slides. I think I need to take a lesson of introduction to Zoom and screen sharing, perhaps. I guess I share the screen and then share. Okay, so everyone see the on Zoom see the slides, right? Perfect. Okay, so let's keep moving. Okay, so we finish all the basic 6 data structures in R. So perhaps at this point, you have a question in your mind. Are these all the data structures I will encounter in R? Unfortunately, no. So there, the correct answer, the even more heartbreaking answer is there can be infinite amount of data structures in R. So our data is becoming like increasingly more versatile. So we need more complex data structures to deal with this kind of data. So new data structures are constantly being like invented by using those basic ones as a building block. Exercise. So within 5 minutes after getting the metadata, so Tom finished the analysis of the RNA-seq experiment. So he points you to a variable named DDS. It's just a variable name, and said that everything related to the analysis, the raw data, the metadata, the results of the analysis is all in this variable. So you check this variable and find that it's something called DSeq dataset object. Again, I do not make this up. So you will rarely encounter this if you are like analyzing RNA-seq data with R. So what happened? So first, Tom is playing a trick on you by just give you a very weird named like data structure. Second, so this data structure can only be opened using some like paid software. Otherwise, you watch like advertisement every 5 minutes for using it. Or C, it's just a new way of organizing data. You can get all you want with a correct way of accessing them. I think I already made the answer very clear because the other two are too ridiculous. So yes, so each RNA-seq experiment will have a counts matrix, as we have already seen, and associated metadata, a user-specified way of how to compare the data. Say, for example, in our case, we want to compare treatment versus untreated. Like this can be more complex. Say, for example, you collect RNA-seq data at each time point of, say, for example, some growing cell or growing plants, and you want to compare how each time point is different from the previous time point. So the comparison formula can be very complex. And finally, you also have the results from the comparison, which we call the differentially regulated genes. So if all these data are just scattered as individual variables in your R, then it can become very very messy. Like they are like mixed with other variables you define during the analysis, and when you want to pick them out, you need to like try to come up with the name. So the developers of the DSeq2 package feels that it would be better if we can have a data structure to group all these data together and organize them in an easily accessible way, such that throughout the analysis, you only handle with one variable. So this is what exactly is behind the DSeq data object. So it's just a way of organizing all those data together as an object. Say, for example, if you want to get the counts matrix from the DDS, the DSeq object, then you just use the function, or like here you can see it's just some magical words, counts. And then it will return the counts matrix to the counts matrix variable. Similar, if you want to get the results, you can just use the results, and then you will get the DE-seq results. And you can convert this result to a data frame, and then you handle it just like how you handle any other data frame. So just a brief touch, even if you don't understand this part, it's perfectly fine. So why is it called object? And also frequently you will see some horrible stuff like S4 and S3 class, those kind of stuff, you understand every letters in it, but when they are connected together, you don't understand. So it's nothing special. It's just some way people use to create those complex data structure called object-oriented programming, OOP. So object is just a member of a class. That's all you need to know. So class is a general concept. Object is a specific case from that general concept. And why it's called object? Because programmers use this way to create more complex data structures. That's all. So a conclusion for section 2. So we can put different data into different data types in R, the numeric, character, factor, or those kind of stuff. Then for more complex data, we can organize them into a suitable data structures to make our life easier. Of course, if you choose the wrong data structure, your life will be more miserable. Say, for example, you try to store replicates as a matrix, then your life becomes more miserable. And new data structures can be customized for a specific type of data as an object. Yeah, it's just a word, object, so don't worry. Okay, now we end section 2. Let's move on to section 3. So analyze data in R, or a more fancy name, function and flow control. So going back to our 3-step analogy of analyzing data in R, now we are at the final step. So good. Analyze it with R. And in section 3.1, we will first learn something called function. In fact, it's not something new. We have already seen it. At that time point, I frequently refer to it as some magical words that you parse to R, and then let's say, for example, this C followed by round bracket give you a vector. So all these kind of stuff like C blah, 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 or matrix blah, 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 word followed by parenthesis or round bracket is used to call a function from R. So what does a function do is that function has a predefined workflow hidden inside it. You don't see at this moment. And this black box takes some input from you and generate an output according to the predefined workflow within that black box. So the import in R and throughout this course, we will just call it the argument of the function. And we will have the outputs based on these inputs. So how to separate each arguments, because a function can take multiple arguments. It's not limited to just one. So to let the function know that, oh, this is one argument, this is the second one, this is the third one, you separate them by a comma. And finally, the function name, similar to the variable name, must exactly match the one you want to use. Say, for example, to define a matrix, it must be matrix like all in lowercase, and matrix, it cannot be capitalized, capitalized for the first letter, sometimes missing the one. So they will all not work as R will not recognize it. It wouldn't guess what you want. RStudio will try to just confirm which is the one you want, as I shown before. So then let's take a deeper look at one of the functions we use to create a matrix. So this part, the example matrix plus the arrow sign, perhaps we should be already quite comfortable with it. It just means assign something to a variable I made. Perfect. But this part is still the matrix, whatever this long line is still like confusing. Like I think you have 3 questions in your mind. At least that's the 3 questions I have in mind when someone first taught me like programming. I was like, the first question is the most obvious one, like how do I ever know that I need to put these 4 arguments to the function? Like you give me matrix, like how do I know I need to put a vector here, unroll, uncall, and byrow here? I can't even know the name of the argument, right? And why does and if you take a deeper look at it, it seems the first one is like different from the following 3 is because there is no blah 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 equal in front of this, the C 1, 2, 3, 4, like in front of that vector, unlike the following 3 where you have unroll, uncall, and byrow. So why is that one missing? And finally, perhaps the most ultimate question is, you will realize is that if I do not tell you this function, you should use this function to create a matrix. All the goddamn well, you know how to create a matrix like in R. So we will answer these functions like one by one. So first, how do I know I need to put these 4 arguments to a function? So you can read the technical document for the function. It's just like the user manual when you buy like a phone, although we typically wouldn't read the user manual. But it's important that you read the user manual of the function. So how do you like get the user manual of the a specific function, assuming that you already know the function's name? So you can use the question mark followed by the function's name and then run it. And the document will automatically pop up in the bottom right of RStudio. So I will save the demonstration to the end of the class just to avoid like switching back and forth to waste time. So the instructor who taught me R says that, do you know what's the most useful function in R? The question mark. Yeah, so don't ask me, check the question mark first. Yeah, so of course, nowadays, internet is quite powerful. So if you search the function name and with some keyword like R, you can also bring up, Google will also bring up the document to you. And of course, you can always go to like those forums like Stack Overflow, where there are lots of professional and lots of good programmers gathering there, answering questions voluntarily, like or blogs or websites to read explanations from other users is also fine. Nowadays, you can also turn to AI or ChatGPT. So I will show you how, like at each time point, what you should decide to take and how do you like switch between these 3 scenarios. So first, let's always start from the beginning. Let's read the technical document. So this is written by the guy who write this function. So this one should be the most like, I'll say the gold standard one. So I have already bring up the screenshot of the document. If you type question mark matrix. So first, the first line, the usage line, we can see what's the overall like arguments available to this function. So we have data, and row, and column, by row, and then names. So this means in total, we can put 1, 2, 3, 4, 5 arguments to it. And then after the first line of explaining the usage, you will have a more detailed explanation telling you what's the meaning of each argument, what it is expecting, and what you can write to it. Say, for example, say something like, oh, an optional data vector, including a list or expression vector, like non-atomic class R objects are coerced by SD dot vector and all attributes discarded. It's I don't know how you feel. For me, it's every word I know, but when they are connected together, I don't know what they're talking about. So, so before we switch, so finally there are details of the functions. So this is following the explanation of the arguments. Again, so like if one of enroll or encode is not given, an attempt is made to infer it from the length of data and the other parameter. If neither is given, a one-column matrix is returned. This one is perhaps slightly better than the previous one, but still it's not immediately clear to you what it's trying to say. And to confirm you are not alone. Like even I sometimes when I read the documents, I was still like, what is he talking about? So the reason is because the technical documents are written by the developer of ours or the specific packages like containing that function. So these guys are perhaps too good at R so that they frequently assume some concepts are just common sense to the readers, which are actually not. So, and the one we read is already a very well-written one because it belongs to the built-in function of R, which many people use. So already lots of efforts has been put into writing the document of that one. But still you can see it's very not reader-friendly, especially for novice. I mean, in the future, you will encounter like more and more functions. Some of them, the developers are not even bothered to write a very standard description to it. So it would be even more confusing. Perhaps the only guy in the world who can understand it is the developer, he himself. So then what can you do in this case? Like, anyway, you wouldn't be able to understand that documents. So in the old days, it's really miserable. You need to like go to forums, asking people, anyone have used this function in the lab? And there is a last scenario, like last resort is try to read the source code of that function to understand what they're doing. So nowadays, things are completely different. So we can just ask we can just ask AI to explain to us. And turns out AI are pretty good at it. So here is a screenshot I use on my ChatGPT account. I just say, oh, can you explain to me how the matrix function are infer out uncore or enroll when only one of them is given? So this is exact to remind you, this is what this sentence is talking about. So you see, I see that it says, oh, you only need to give me one argument and I can try to infer another one. But like, how does it work? Like, you must be wondering, like, and then it just, AI just say, okay, the core idea is a matrix is just a vector with a dim attribute. When you call this one, R knows the total number of elements equals to the length of the data, which means when you give it a vector, R knows how long that vector is. I mean, if you feel this is still too abstractive, you can ask AI to further clarify it. The number of rows or columns you have given, okay, you give one of them, say for example, n row or n column. And the other dimension must satisfy this formula, which n row times n column equals to the length of data. That makes sense, right? So a matrix will have, say for example, a 3 by 3 matrix will have 3 times 3 equals to 9 elements in it. So, and given that you are asking R to converting a vector for you into a matrix, then the number of elements must agree. And constant, and therefore R can just use this formula to derive or infer what's the number of rows and what's the number of columns, as long as you give it one of them. So this is very useful that in some case, you are only very sure about one like dimension of your data. Say, for example, I have 3 conditions. And now I have 60,000 reads or 60,003 reads. I know because it's 3 conditions, I definitely will have 3 columns. But to be honest, I too lazy to bother how many rows there is, but whatever gives me 3 columns is correct. Then in this case, you only need to pass the number of columns equal to 3 to this matrix function. And it will return you the correct matrix because it will automatically calculate or infer the number of rows based on this formula. And AI is also super nice to remind you it must divide exactly, which means if you give R like a vector of length 9, and then you say you want 2 columns out of this 9 data, then the number of rows is 4.5. There is no magic R can deal with it. So yeah, you see it's pretty nice, like quite considerate. I didn't ask and it's already reminds me like, oh, it needs to be divided exactly. Okay.
What happens if I just copy pasted the technical document into ChatGPT and then I say, what does this mean? And then
Oh yes, that would also work. So thanks for reminding me. That's the exact what I will say for here. So for to call a function or to call a variable name in R, you must use like the name must specifically match and all those kind of stuff. But when you are asking AI, you don't need to follow a very strict grammar. Just feel like what you are talking to your human colleagues, phrasing your questions. The only thing I want to add is that perhaps it would be helpful if you tell AI you are using R. Otherwise, it doesn't know whether you are using Python or R or C++ or whatsoever. So usually you just say, oh, what function I'm using, and this function is from R, and then it will tell you, okay, what you explain all this stuff to you. And of course, if you feel any of the point is not clear, you can ask like, oh, what do you mean by length round brackets data? It will again explain to you. But of course, just like human being, AI can be wrong. At first, we don't think AI should be wrong because they are trained statistical models. But as things get too complicated, I don't know whether you have heard this word or not. So hallucination of AI. So which means AI tends to think it understands something, even though it doesn't understand, just like human being. So at the introduction of the first generation of AI model, like the ChatGPT 1 or whatsoever, hallucination is still very severe. So like it's a 50-50, like it will like fabricate like literature that doesn't exist to support what it wants to tell you. Nowadays, I would say the literature problem still exists, but for coding part, it's getting much, much better. So hallucination is much less encountered, especially when you are asking coding questions, likely because there are so many coding-based forums and blogs offering high-quality content. So, but the whole world of literature is still full of junk data, junk paper, and weird stuff. So AI is surprisingly good at telling you how the code works and how explain the details to you. And if you say, but still, if you feel something AI says does not make sense, so what you can do is that you can first ask follow-up questions saying that, hey, I think this doesn't make sense to me, like because it seems to be contradictory to what's written in the technical documents. So usually AI would be able to correct their own mistake through their own logics, or clarify, like in many cases, I find that it's not AI is wrong. AI is not wrong. Technical document is not wrong. I'm wrong because I misunderstood both parts. So yeah. And finally, combine AI's answer with your own understanding toward the technical documents to have your own understanding. Like that's usually how you digest the answer from AI to make sure you fully understand it in the correct way. Okay, so we have the first question answered. So the answer is you need technical documents, and you can read it with the help of internet and AI. And then the second question is that not from the technical documents. I guess you know that let's have a quick test here. So what do you think should I put in front of the vector, which is the C blah blah stuff? Am I missing something? Based on this, based on the usage of the based on the description of how to use this function. Okay, am I missing something in the code? I'm missing the data equal, right? I didn't put the data equal in front of my function for defining a matrix, right? Well, of course, I guarantee you the code still runs. So why does the first argument do not have the data equal as specified in the technical documents? So first, the answer is I'm lazy. So that's really the answer to most of the questions. But most importantly, I'm allowed by R to be lazy in this case. So what's the rule of being lazy in R? Yeah, that's actually the most important part, how to being lazy. Whenever you are giving a function the argument it needs in the order it specifies in the technical document without skipping any argument, then you can omit all the argument name, which means you don't need to type data equal, nrow equal, ncall equal, byrow equal, daemnames equal. As long as you are giving the function these arguments in the order specified here, data first, nrow second, ncall third, byrow fourth, daemname fifth. But when do you need to give the function name, the argument name? Is say, for example, remember that nrow can be inferred from ncolumn, right? Then in a case, if you want to skip nrow, then the first one you can still omit because R will assume it is the first one. But if you just give it 3, then R will think, oh, this guy is giving me the second argument, which is nrow. But what you intend is ncolumn. Then you need to tell R, okay, wake up, dude. This is not nrow. I want it to be ncolumn. So this is the moment you need to specify the exact argument name out. Of course, if you omit, say, for example, the last one, and all the ones in front of them are in the order without skipping, then you can also then you also don't need to do. It's only when you skip an argument in the middle of the order, then for the remaining ones, you need to give it the argument name. So,
I noticed they said that for Boolean arguments, in this case, they say it's by default false. Is that true for most things in R, where if you don't specify a Boolean true or false, they'll assume it's false?
Very thanks for just naturally bring up the next topic. Okay, so what he's asking is the default argument. So you see, I didn't in my previous function, I didn't even put the dim name argument, right? But the function still work. So this is due to the existence of the default argument. As you can see here, everything actually already has something it equals to. This is called the default argument, which means if this argument is skipped by the user, R will assume the user means this the default input. So this just means for functions with 100 argument, you don't need to put 100 input to it every time you use it. For whatever ones you don't care, you leave it as default. And then he is asking, is it true that R will always make the default for any Boolean logical argument? Will it always be false? No, it's not guaranteed. Sometimes it will be true. It's all depends on the developer of the function. If he feels most people will use this argument as true, then he will put the default as true. Yeah. So the rule of being lazy is that, okay, so when you don't want to type in the argument name, then you must supply the argument in the order as specified in the technical document without skipping. if you don't want to specify the value of some of the arguments, then you just take the default, keep in mind of it. If you want to know what's the default, then go to the technical documents. Okay. So yeah. This is So this is how we can be lazy by omitting the argument name. This is when you cannot be lazy. Of course, a side thing is that you see here, I still put the unrow and uncolumn. So first, you can in the case where you can skip, you of course have the freedom to put them here. And you will see also many people choose to still put them here. Because if you read it like this, to be honest, in most cases, you don't understand what's that 3-3. Yeah, sometimes putting the argument name clarify it to you what it's actually doing. Like the first one is too obvious that virtually everyone knows, but you will soon also think it's common sense that it's the data. But for the following two, like who is unrow, who is uncolumn, like you never know. Like it's easily forgotten. So we will talk about this kind of good practice when you're writing code at the end of day 3. Yeah. Finally, the ultimate questions. If you don't tell me this function beforehand, how can I even know what function to use to create a matrix? And this can be generalized to all the stuff. If you don't tell me the function, which one to use, how can I know, like, does it even exist or not? So first of all, this is not something specific to a novels. It's very, very common that you, like, it's a problem known as so-called reinventing the wheel, which means you spend like lots of days, like writing hundreds of lines of code and end up finding that, oh, actually there is a function that can solve this problem with just one line of code. So I've read that this is not a story about R, but a story about MATLAB, which is another programming language. So a master student write all his thesis, and at the end of the second year of his master, he finds that all the code he writes can be solved by one line of MATLAB code because the engineers at MATLAB already implemented it, and it's way faster. So yeah, so clearly he is reinventing the wheel by doing something some people have already done for you by packaging everything into a one-line function. But how do you dig that function out? Because you don't know the name of it. So in the old days, you need to do something like a literature review. So now you cannot even read the documents because you don't even know the function name. So you go to forums, you go to blogs asking, oh, I want to do this. Like, does anyone know, like, is there a function that can help me do this? So nowadays, just ask AI. So let's assume a case where you don't even know how to create a matrix in R. To be honest, I sometimes also forget. Yeah. So in MATLAB, you don't need a function. You just use square bracket to create matrix. So after spending some time in a MATLAB project and then go back to R, I forgot how to create a matrix in R. I just ask AI, like, in the old days, I will search on how to create a matrix. Now I just ask AI, okay, how to create a matrix? And then I say, oh, it's the matrix function, not mat, not mat dot whatsoever. It's matrix. And then it will show you an example. And with this, like, in mind, again, AI can be wrong. So it might give you a function doesn't even exist. It can happen, especially for those functions that are not commonly used. I don't think AI will get a matrix wrong, but in the future, when you work in a specific field, dealing with a function that only that field use, there is still some chance AI can be wrong. Because the fewer people use it, the fewer AI can learn from it. So the AI tends to, like, the higher chance it can be wrong. So once you get the function suggested by AI, the first thing you should do is using the question mark plus the function name to to pull the technical document out. So this confirms first, this function indeed exists in R. And second, you can read through it to check roughly, does it agree with what AI tells you? Like sometimes even the name exists, but actually that's a function doing a completely different thing. That's still possible because AI can suffer from hallucination. If there is disagreement or something unexpected, you feel that like part of it is correct, but part of it is not correct, you can ask AI with follow-up questions and suggestions, asking it to clarify it for you, give it a chance to correct its own hallucination. But in many cases, perhaps once you read a technical document, you kind of know how to use that function. Okay, so one more exercise. So after inspecting the R codes for analyzing the enzyme activity before drug and data before and after drug treatment, so Tom, the troublemaker, says that, oh, perhaps it's not good for you to use t-test to test whether the two measurements are significantly different from each other. Oh, so I guess some of you perhaps haven't, especially, are there any undergrad here? Do you know what's t-test? It's just a magic telling you whether two different data sets are truly different from each other in mean or not. So it's like you throw a coin for many times. Sometimes it's front, sometimes it's back, but you cannot but how can you judge whether a coin is fell uniform in the distribution of the front and back weight? So it's a test that you can tell that what's the probability that this coin is actually biased towards one face or not. Yeah, don't worry, you take the statistics and it has nothing to do with understanding this course. So what Tom is saying is that, okay, so the t-test assume your data follow normal distribution. Yeah, anyway, it means the t-test has some presumption about your data, but perhaps your data doesn't meet that presumption. So the best practice is to use another t-test invented by another guy called Wilcoxon rank sum test rather than a t-test. So your supervisor agrees with Tom, and most supervisor will do, they will ask you to show them the results immediately. So what you should do. So first, dig out your lecture notes from statistics 1001 to see how, to first understand, okay, how the Wilcoxon rank sum test works. And then based on how it works, you write the codes to reproduce it in R. And second, so you can try to find some function that can do it in R and modify your code accordingly. And C, open RStudio and do the test by running Wilcoxon rank sum test before treatment, after treatment, because R is so powerful. So it must have this function ready for you. I think I make it too ridiculous, right? The other two authors. Yeah. So first, A might work and can be the only solution if no function exists in the world for R to do this test. But the price is that your supervisor may not be as patient as you. So for C, usually it's a good practice to name a function based on what it is doing. But still, it can be very difficult to guess that out if you don't have the function name in your mind. Say, for example, for Wilcoxon rank sum test, it can be separated by underscore or by dot, or people may omit the rank in between. And by the way, it's definitely not Wilcoxon space rank space sum space test, because just as mentioned for the variable name, function name cannot contain space in R. So you definitely know it's not this one. So B, given that this test is suggested by one of your colleagues, directly in front of you without consulting any literature, so it's highly likely this test is famous enough such that it deserves a function in R. So that's the typical way I usually when I want to implement something in R, I will first ask myself, okay, how many else people in the world do you expect to do this before you? If the answer is no one, perhaps the chance of finding this function is quite small. But for such a well-known test, I guess the probability is very high. So the next step is, okay, ask the AI how to do well-Coxon rank-sum test in R. And then here I also specify a little bit. So I have the data to test as two separate vectors. Because I want a function, I already have my data available in two vectors. I want a function to be able to take these two vectors as input and do this for me. So I'm kind of trying to refine the answer such that AI gives me another function that requires me to do some reshaping of my data and then work. So I'm lazy. I just say, is there a function that directly working this way? And AI say, of course, there is. So you have your, say, for example, you have your first sample as this, your second sample as this, then you run, well-Cox.test. So they omit the rank, they omit the song in well-Cox song, and then join them by dot. Like, how can you guess that out if you don't know the name? And then X and Y, and it will tell you, oh, this will give you the statistic, the test statistic, the p-value, and the alternative hypothesis by default. Then what's the next step to do? You use the question mark plus the name suggested by AI to bring out the technical documents of this function. And okay, the good news first is, oh, you indeed see a technical document pop up, which means this function indeed exists. Then you begin to see, oh, yeah, it takes two arguments. It can take X and Y, and then here it explains whether like how X is a numeric vector of data values. Makes sense. An optional numeric vector of data values. So, which means this one is optional. So just a side knowledge, perhaps to clarify to you why sometimes it only takes one X. It's because it just tests whether it's different from 0 or not. Yeah. When you give it 2, it tests whether these two are different from each other. When you give it 1, it just tests whether it's different from 0 or not. So what we should do is this is our code before, and this is our code after. So we just change this line to this line by calling the well-Cox.test function rather than the t-test function. So problem solved. Everyone is happy. But you are happy too early. So when you run the code, so again, so in the outputs console, you will see, which is at the bottom left corner of RStudio, you will see first it will type well-Cox rank-sum test with continuity correction. Okay, so you are running the correct test. Data before treatment and after treatment, that's just the variable name you pass to that function. Okay, so it tells you W equal to 0, p-value equals 0.02843. For any people who do biology long enough, you immediately like realize, oh, this is smaller than 0.05, so good. Then null hypothesis is rejected, and I can publish my paper in Nature. So yeah, so for those of you who do not understand, so this is the probability. The probability that the two data sets are actually the same, which means before treatment and after treatment are the same, which means your drug doesn't work. Yes, it's that cruel. But it's always a probability. So what we judge is really whether the probability is large or small. If it's very high probability your drug doesn't work, then it's likely it doesn't work. But if it's very small, then it's likely your drug still works. And 0.05 is very commonly used, very commonly criticized, but still very commonly used cutoff, arbitrary cutoff for that one. And alternative hypothesis to location shift is not equal to 0, which means the difference between the two data sets is truly different. Again, this is our programming course, not introduction to statistics, so we won't talk too much about that. But then you see something written in red saying that, okay, warning message. So in Wilcox.test.default before treatment, after treatment, cannot compute exact p-value with ties. Again, that's something like every word you can understand, but when they connect it together, you can no longer understand it. So first, if you see a warning message, it means your code runs without any problem, because otherwise it would be an error rather than a warning. But still, warning, do not then say, oh, my code runs, yeah, everything works. Warning message is that if R feels that something doesn't prevent it from running the code successfully, but still worth to be brought to your attention happens, R will give it to you as a warning message. So do not ignore it brainlessly, because frequently they can still mean some problems. So similar to technical documents, whenever you get a warning message that you feel are difficult to understand, which is quite normal, you can again turn to AI and other resources for a more detailed explanation. Wait, so I didn't have AI's explanation to me. Okay, yeah, I didn't do the screenshot of AI's explanation. It turns out it's just like the tie, the tie with ties. It doesn't mean like the tie you wear. it means in your in the data there is a tie like 1 and 1, 10 and 10. They are equal in value, so they are a tie during ranking. So the Wilcox rank sum test cannot rank exactly 10, 10, 1, 1. It's just like they are equal, so you cannot assign who is smaller, who is bigger. And when this happens, for the inherent like mechanism of Wilcox test, it cannot give you a very accurate p-value. Instead, it needs to give you an approximated p-value. So it has nothing to do with the code is wrong or whatsoever. It's just inherently for the mechanism, from the mechanism of Wilcox test, doesn't allow you to have an exact p-value when you have ties in your data. So all in all, for this warning message, it's safe to ignore. So it just but anyway, the p-value is still valid. It's just an approximation, not the exact p-value. Yeah. And again, you can try it as a homework, like say, okay, there is a warning message are sent to me saying that it cannot compute exact p-values with ties. I guess the answer AI gives you still need some statistical background to understand, but yeah, once you have that, you will be able to understand it much easier. So there are a lot of we have just learned a few functions and how to use them, and there are perhaps almost endless amount of functions in R to help you do lots of different stuff. So we will learn like you can import external data into R with a group of functions. You can create and manipulate data structures like data.frame we have already seen, matrix we have already seen. But once we create them, we can use different functions to like manipulate them, like reshape them, or add rows and add columns to them. We can do simple like calculation of statistics, like calculate the mean or variance, do statistical tests, like we have already learned 2 statistical tests here. And we can fit statistical model, or more fancifully nowadays, machine learning models or AI. Like machine learning is no longer fancy nowadays. Sorry.
Is machine learning just a fancy word for statistics?
No. Let's see how long we have. I still have 30 minutes. Yeah. So regarding the buzzword of machine learning. So machine learning, so it's like this. Part of statistics deal with a concept called statistical learning, which can be regarded as equivalent to machine learning. But statistics itself is not equivalent to machine learning, because statistics deals with a more broader topic that's studying the data and statistics and trying to get things out of it. Machine learning deals with a more specific topic within statistics. That's given statistics, how can we have the machine, which is computer, to get the inherent like patterns or knowledge out of it. So in the reason why learning sounds so sexy and so like popular is because in the old days, we human beings try to learn it out on our own with the help of function like this. So it's like the statistician sit in front of the computer and then like use all those functions, try to learn something like on our own. But later, when we find that, and then once they learn something, they formalize it into their theory and then try to predict how the world operates. Sometimes it's correct. Unfortunately, in most cases, it's wrong. So people begin to think, okay, if human being is not good at this, can we have the machine do this? Because human being needs to eat, needs to sleep. Machine can work 24 hours, 7 days, 365 days per year. This comes to the topic of like machine learning, where people try to use design algorithms like those random forest models. So this is a model frequently used in machine learning. So it's essentially you give the data to the machine, asking it to fit certain model it believes fits the data, and keep optimizing it until the model is good enough. Then the model is machine's theory towards this data set. And you can ask them to predict the world or the real world data to see whether they agree or not. Turns out, in many cases, it does better than human being in the sense that or equivalent or just slightly worse than human being. But machine doesn't need to eat, doesn't need to sleep. Like on your Tesla, like you don't have someone sitting there say, oh, you need to brake, you need to like speed up. You handle everything to the machine, learn how to control a car. But still you see news that Tesla make a mistake and people dies. Yeah, they are still not perfect. So long story short, so machine learning or statistical learning is just one subfield of statistics. So if you, given that this is asked, I will recommend you a book of, if you want to do machine learning with R, so there is a very good textbook. I will recommend this to you at the end of the class. So yeah, it's really a good one. To be honest, it can even replace me because it also teach you how to use R. Yeah, so this list never ends. By the way, the GLM model called generalized linear model, that's the model used in many packages to pick out genes that are truly different across conditions in like omic level data, like RNA-seq. So how do they like, because your data is collected usually in different batch and there are usually lots of noise in the data. So how do you discriminate between those variation introduced by batch and noise, and only try to pick out the true biological difference? The idea behind it is a generalized linear model. So again, all this stuff, you can do it in R. So, and the most important thing is that this list never ends. So that's why in this class, I do not attempt to teach you one function by another, because it's impossible. It's just impossible. Yeah, so for section 3.1, so like let's have a temporary conclusion for this part, which is called function. So what is function? So they are powerful prepackaged functional units in R capable of helping you do all those kind of sort of data analysis, such that you don't need to write a code from scratch. So you need to supply the required inputs to the function. And regarding that, you also keep in mind the rule of being lazy, like when do you need to type the argument name, when you do not. And finally, I think this is the most important thing. So if you have a specific task in your mind to solve, how do you find the function? So you first find the function by AI or go to whatever resources you want, but most frequently you should first try AI. And then understand the function by reading the technical documents or go to different forums asking for third-party opinion. Then you finally run the function to confirm whether the output agrees with your expectation or not. So this is how you find like solve specific data analysis tasks in R. Like I myself still use this kind of thoughts, like when I need to analyze a new type of data. Yeah. So conclusion for today. So I guess this one is the most important thing. So many people who begin to learn R and many instructors of R or other programming language tend to teach it in a stamp collection manner. It's like, oh, this function is very important. Remember it. That function, you're also going to use it frequently, so you need to remember it. So at least I do not believe in that. So because the reason is that there are thousands or actually tens of thousands of functions available in R. I also don't know what field you guys will work in eventually. So there is no way for me to guess out which function is most useful to you. So therefore you should, if you want to leave. Yeah, so therefore there is no need, there is no way to teach you all the functions you will use in R. And it's also impossible and unnecessary to memorize those functions. Like for the function we learned today, I don't even expect you to memorize that matrix one. I mean, there is no need for you to memorize that. Like when you need to use it, just ask AI, how do I create a matrix in R? It tells you matrix. Yeah. So all you need to learn is those data type, data structure. So those are the rules of R. So it's like playing a game. You do not try to play in ping pong by like my Mac ping pong player, like, oh, you first do this, then this, then this, hit the ball. So you just learn some basic stuff like, oh, the ball cannot, you need to keep the ball within the table, and once it hit the net on your side, then you lose 1 point. And once you have these rules in your mind, then you just play this in R in whatever manner you like. So, and then you discuss with AI and other people to see how you can make it even more interesting. So this is how we will learn R throughout this course, and keep this in mind. So don't go back and begin to memorize the functions I give to you. Okay, so we reached the end of the slides today. We still have pretty much of time. So then I will demonstrate to you how to use the in RStudio to see what happens. Let me see whether I get better at screen sharing. Yeah, so for all people on Zoom, can you tell me whether you see the RStudio and is it moving?
Yes.
Okay, perfect. So first, let me demonstrate how to use the most useful function in R, which is the question matrix, the question mark. So what's the, oh, it just says yes. So again, you type question mark followed by the name of the function you want to know about, and then you can click run, and the documentation of the function will pop up in the bottom right corner. I mean, you can drag this window to make it easier for you to read, and then you can just read through it. Yeah, it's pretty handy. Now, by the way, if you wonder where is my plots, you just click here to go to the plots panel. So it's not deleted. So this is help. This is plots. Okay. Yeah, then let's just run the Wilcox rank sum test. Again, click. Okay. So because this is text output, so it's output at the console here rather than the panel here. So you also see the warning message, right? Usually those stuff that worth your attention is in red, so you can just read it. And because like sometimes if there are lots of stuff in a console, like if you are someone who hate messy table, you will feel it's uncomfortable. So you can just use Control plus L to clean the output. So you now have a clean output. Okay. Yeah. So that's it. So that's all for today. Let me see whether we have anything missed out. Yeah, all this stuff, if you want, you can install RStudio and run in it. One more thing. So for anything followed by this number sign, it is a comment, which means it's not something intended for the machine to read. It's something intended for you and me, human being, to read. So anything followed by the dollar sign will be treated as comments and immediately ignored by the machine, so it wouldn't trying to run it as a code. Yeah, and RStudio is quite nice, so it helps you highlight it as green, so give you a clear difference. Okay, so fine. For those who are interested in that book regarding the statistical learning with R or machine learning with R, yeah, just let me Google it out and recommend it to you. Okay, so an introduction to statistical learning. Statistical learning is just another way calling machine learning. I think when I learned it, it's only with applications in R, but perhaps nowadays many people are also interested in doing it in Python. So you also have with the application in Python. But anyway, if you want to learn statistical learning, which is quite useful in R, so you can read this book. I think in the first chapter, it's first briefly teach you how to use R. Not as good as me. Yeah, not as thorough as me, perhaps. And then for each following chapters, it tells you, it discusses one type of statistical model and what's the theory behind it, what's the mathematical formula behind it. To be honest, you don't need to understand it, but just have a feeling of it. And then it will teach you how to implement this statistical test or statistical model in R. It's really a sharp contrast. Sorry, I think I did lots of. So it's just people praising. Oh, some medium. Okay, I think, yeah. For Maria, I will answer your question individually. Yeah, so really it's a sharp contrast that there are tons of mathematical formulas, and when it comes to how to implement it, it's only one line in R. Yeah. So, and they also will give you some interesting homework for you to do, and you can immediately learn how to analyze real world data set. And I promise you, those kind of stuff can migrate to your real field application, which is quite good. Yeah. I think during my first year of my PhD, I worked with a psychiatrist to analyze medical data. Oh, by the way, my PhD is in biomedical engineering. I'm not a psychiatrist. To analyze like what factors make doctors overtreat a psychiatric patient. Is it how long they stay in hospital? Is it their age? Is it their specific type of the disease? So you have many features and you want to pick out who is the most important factor. So after you read this book, you will know how to do it in 100 different ways. Yeah. So that's all for today. And we will gather here tomorrow to keep our journey with our, tomorrow will be even tougher, but hopefully you are prepared for it.
And for the homework, if we're taking it for a grade, will you email us individually?
Yeah, I
Oh.
will.
Thank you. Thank you very much. See you tomorrow.
See you. Maria, can you hear me? Yeah, anyway, I will just type the response to your question in.
Yeah.
Yeah. Maybe that fits. Yeah. Is your jacket?
No.
Figure it out. I'm gonna go,
Oh, perfect.
stop recording.
I stopped the record.
Sorry.
I think I paused it. Let
Stop.
I